Okay, so we're going to do some derivative finding, aka slope finding, from a graph. And we're going to be writing equations of a tangent line, which is a pretty important idea in calculus. Because if we know the equation, then we can estimate different things. So let's see, here we have a graph of f. I'm assuming this is f. I think this should be f. And we're going to answer things about f prime, which is the slope slash derivative, right? This means derivative. So the slope of particularly the tangent line. So we're looking at the slope of the tangent line at each of these points. So at -7, right, is this going to be a fairly steep or not fairly? So let's see, 1, 2, 3, 4, 5, 6. Yes, this is -7. The tangent line would have a slope of about, what do you think? If this were our tangent line. Maybe not 3, because that would be 3 up and 1 over, which would get us to that point. That means it crosses at 2 places. So how about if we go a little bit more than 3, which would be 4. Let's have it be an estimated slope of 4. So the estimation of a derivative is 4. Since we don't have an equation, right, we're not going to do the difference quotient. Is the function increasing, decreasing at a relative max or min? So looking at the y values here, what are the y values doing of our function? Increasing. So we're going to write increasing in here, and we're probably going to make some general statements towards the end of this based upon our increasing and decreasingness. Right, the equation of the tangent line. Okay, so we're going to use what's called the point slope form. So y minus y1 equals m times x minus x1. This is the point slope of our equation. So we have a point at x1, y1, and the slope is, of course, your derivative at that point. So what is our coordinate for x equals -7? -7 and -3. Okay, so this is our x1 value is -7 and our y1 value is -3. So we're going to use the point slope form, and in AP Calculus you don't have to reduce this. So this is y minus, let's see, -3, right? That was our y value up there of our point, equals m. That was our slope. Our slope was 4, right? And then x minus, the x value is -7. Maybe a little bit of a simplification. Minus a minus will always become a plus. We can change this minus a minus to a plus, y plus 3, and we can change this minus a minus to a y plus, or x plus 7. Okay, that's all the linear equation that we need. We don't need to put it in y equals mx plus b form. That point slope form is enough. Okay, so we're going to do that same thing with all of these points in our table. Okay, and then we're going to answer some questions about it at the end. So there is all of our tables filled out for these graphs. So based on the table, what inferences can you make about the value of the derivative and the behavior of the graph? So let's see, we have 3 different types of values. So what happens if our derivative is negative? Right, so find all the negative derivatives. And what is our middle column doing if we have a negative derivative? Decreasing. So if our f prime, if our slope is negative, then our graph is decreasing. The y values are going down. All right, they're getting more towards the negative. If your derivative is negative, then your f value is decreasing. Your slope, your graph, the y values are going down. What happens if our derivative is equal to 0? What do we notice about equality? Right, so it's at a max or a min. And it's at a max or a min. If our slope, if our derivative is 0, then our function is at a maximum or at a minimum. And what can we say if our slope is negative, right? So, I mean positive. What if our derivative is greater than 0? What are the y values doing? Increasing. F is increasing. So we're trying to draw a connection between the derivative sign, right, if it's positive, negative, or 0, and what's happening with your graph, right? Because it's a pretty important connection between derivatives and the graphs, between f and f prime, right? So f prime is talking about the slopes, and f is talking about your actual graph. So let's see what the backside of our notes has for us today. So numerically, the value of the derivative at a point can be estimated by finding the slope of the secant line that passes through 2 points. Remember, that was your y2 minus y1 over x2 minus x1. Or f of x plus h minus f of x over h, right? The limit as that went to 0. So any 2 points, we can estimate the derivative by finding the slope of the secant line. So let's do that for a minute. Our x value of 0. So if we're going to have an x value of 0, we're going to use the 2 points to the left and to the right in order to estimate our slope. Okay, so we're going to use the points to the left and the right. So we're going to call one x1 and x2, and we're going to call the ones corresponding y1 and y2. Okay, so if we want to figure out what's happening at 0, what is the slope of the line here at 0, we're going to use some points around 0 to estimate it, right? This is not going to be exact. It's just going to be an estimation. Okay, so y2 minus y1, negative 3 minus 2 over x2 minus x1, which is 1 minus minus 3, is negative 5 over 4. So if we have a negative derivative, what is the function's y value doing there? Decreasing. So can we write an equation of the tangent line? Sure. We do y minus 1, right, because this is the point we're talking about. It's 0, 1. So y minus 1 equals the slope of negative 5/4 x minus 0. You can even write minus 0, and the AP people will be okay with that. But you don't have to write minus 0. It can just be minus 5/4 x. Right, but if you want to put it in point slope form, then we have the y part of your point and the x part of your point. Okay, this seems like this is going to be a lot of work, but we're only doing a couple problems. Okay, so let's fill this in. There, so there's our table. Now, who knows that this is actual, the derivatives, but it's an estimation, right? Because we don't have a whole lot of numbers, we're going to use the ones to the left and to the right, most closely related to the one that we are trying to find. So we're trying to find x equals 6. We're using the points on the left side and the right side in order to estimate that. Okay, let's see what else does it says. The graph of g is picture. So this is a graph of g, right? This is our actual function. Identify the characteristics about the derivative g prime. Okay, so the intervals where g prime is less than 0. So if we look back at our other paper, where are we going to find derivatives that are less than 0? What is the graph going to be doing? G has to be decreasing. So we're looking for the intervals where our g graph is decreasing, where the y values are getting smaller. That looks like it's happening from -4 to -2, right? Here the y values are getting smaller, but our intervals are always coming from the x-axis. So from -4 to -2, our y values are getting smaller, right? They're decreasing. And then as there's another section here from 1 to forever. So from +1 to infinity is also the interval where our slope, right, the derivatives, the slope of the tangent lines would be negative. Right, all we know is that they're negative. We don't know about their steepness. We don't know about their length of steepnesses. We just know that they are, in fact, negative. If the derivative is negative, our y values are decreasing. Intervals where g prime is greater than 0, that must be where g is increasing. The y values are getting larger as you go from left to right. So that happens from -infinity to -4. Right, where your derivative is positive means your graph is increasing in y value. And then again from -2 to 1. Right, we just know that the y values are going up. We don't know what they are. We just know that they are increasing. And then where g prime is equal to 0, that's happening at a maximum or a minimum, right? Those are called your extrema. So we have a minimum at -4. Maybe that's a maximum. A maximum at -4 and a minimum at -2, and then another maximum at +1. Okay, so we have a max and then a min and then a max. So a maximum occurs where your slope changes from positive to negative. Okay, this point is going to be a max because our y values go from increasing to decreasing. Right, your slope changes from a positive to a negative. G prime changes from positive to negative. That means we have a maximum or a relative max. Okay, and then what happens if G prime changes from negative to positive? We have a minimum. Okay, we're going to talk about this type of behavior between our slopes and your extrema all year long. Okay, connections between the graph of f and the graph of f prime. And even later we're going to talk about f double prime, right? And that's going to tell us the points of inflection and where our graph is concave up and changes to concave down. Okay, so just a little bit more about derivative. Remember that derivative means slope. Okay, and there's a connection between the slope of the tangent line and whether the graph is increasing or decreasing.